So welcome back to the next session of alternative building materials course. In the last session, we were discussing regarding the lime pozzolana cement. Okay, so in that lime pozzolana cement, I have been discussed. Okay, how to produce. That means what are the raw materials required to produce lime pozzolana. In that, I have been discussed the limestone. So how it is available in the nature, and in what form it is available in nature, and how we are going to produce those lime. So all those aspects have been discussed in the last session. So continuing with in this session, the second raw material or the next raw material that you are going to use in lime pozzolana cement is the next is pozzolana. So let me go ahead. Okay, what is pozzolana and how to produce pozzolana? So let me first define what is pozzolana. Pozzolana is a material that consists essentially of amorphous silica or a mixture of amorphous silica and alumina. So please note down. So this amorphous silica or mixture of amorphous means it should be non-crystalline. The pozzolana should be non-crystalline. Okay, so I will tell you why it should be non-crystalline. And another thing, whatever the pozzolana material will be there, so it comprises of more amount of silica and more amount of alumina. Okay, it's predominant. Okay, other can say the minerals will also be available. So compared to other ox, that is calcium, ferrous, all those things, silica and alumina will be predominant in pozzolana. So that is a gift. Okay, the pozzolana has got. Okay, next, this is not a cementitious material by itself, but forms cementitious compound, or it will behave as cementitious when it combines with calcium hydroxide at ambient temperature in the presence of moisture. So this is a broad definition I have been given. So very simple, I'm going to explain. So that the aspects are, first thing, it should be amorphous silica or the mixture of amorphous silica and alumina. So this is the first thing. Next thing, what have been stated, it is not a cementitious material by itself. Okay, that means it doesn't comprises of any calcium. Okay, it is not going to bind. So if it want to bind, okay, then it demands an element or a compound which comprises of calcium hydroxide. Okay, it demands calcium hydroxide. That means it may demand lime. Okay, so this lime, okay, the pozzolana will be active or it will behave as cementitious material when only react with, okay, the lime or calcium hydroxide, okay, at ambient temperature in presence of moisture or water. Is it clear? So this is what the definition. So now coming to the very simple way. So that is amorphous means, as I stated, non-crystalline. So whatever the powder or pozzolana we are going to get, it should be non-crystalline in nature. So non-crystalline, why it should be non-crystalline? So the pozzolana will be reactive only when it is non-crystalline. Okay, so this crystalline and non-crystalline we are going to assess by X-ray diffraction analysis. So by performing X-ray diffraction analysis, okay, I think hope you know from the basic physics, okay, that is Bragg's angle. Okay, so from those basics, okay, you are going to apply in this particular X-ray diffraction analysis. So in this, okay, they are going to perform the X-ray diffraction analysis for this pozzolana. From there, they are going to know or assess whether it is amorphous or, okay, I can say non-amorphous, or I can say crystalline or non-crystalline. Okay. And next, as I stated, when the pozzolana, whatever the material you are using, if it want to react, okay, then I need to combine with calcium hydroxide. Why? Because it is predominant of silica and silica alumina. Okay, it comprises of more amount of silica and more amount of alumina. It doesn't contain, okay, I can say the calcium oxide or hydroxide. Did you get my point? So hence, so this pozzolana will be active only when it combines with calcium hydroxide, that is lime and water. So then only this pozzolana will be active. That is the function I can say. Did you get my point? So that's why I've been written. It is not a cementitious material. That means it cannot bind. If I mix a pozzolana and a water, okay, in order to prepare, I can say something a paste, okay, it will not act as a binder. It doesn't got a calcium property to get bind. So hence it will react, or I can make the pozzolana to be a cementitious compound when it combines with calcium hydroxide at suitable temperature in presence of moisture. So that is the definition of pozzolana. And this pozzolana, the name it has came from a village Pozzoli in Italy. So in the Italy, one of the the village is called Pozzoli. Okay, that Pozzoli, why they have been kept? Because unknowingly, when the volcanic eruption has been happened in that time. So those volcanic eruption happens. Whatever the lava or magma that comes out. After that, once it gets cooled down, the left out thing will be the ash. So those ash they used to bind with lime, because at that particular instance the lime was abundantly available material. So they used to bind those material, and they used to make up this process, something like I can say for the construction aspects. So that's why the word pozzolana has came into existence for those materials. Is it clear? So next, so what are the sources of pozzolana commonly available or commonly used? Number one, powder burnt clay. Powder burnt clay, or commonly, we know that it is surki. It is called surki. Next, fly ash. So this is the predominantly used pozzolana, in the entire world. In the entire world, this is the predominantly used pozzolanic material. Please keep this in mind. So whatever the cement bag you people are getting nowadays, which comprise, that is PPC. They used to say PPC. That is Portland Pozzolana cement. So that pozzolanic material they are using inside the cement is, or they are replacing the cement is, fly ash. I will talk more about these materials in this particular module, because we need to thoroughly understand the what is fly ash, how it functions, everything. And the next is rice husk ash. So this is the one more pozzolanic material next to the fly ash they are using. And this also they are trying to replace the cement. And they are getting a good results. I will tell you all those things. Next, let me discuss one by one. So first, powder burnt clay. So let me go ahead with powder burnt clay. So what is this powder burnt clay, and how to produce a pozzolanic material from this material? So let me go ahead. So now this can be made either by artificially burning the clay in a kiln, or by waste of burnt clay material like bricks, tiles, and pottery. So please remember, so if I want to produce the pozzolanic material with the help of a clay, artificially I need to burn the clay material or a soil, or else whatever the bricks, tiles, pottery have been produced. So those material, that means, for example, if the brick is overburned, if the tile is of not of proper shape, that is manglue tiles, not a vitrified or clay tiles. Sorry, I can ceramic tiles. Or I can say potteries of clay material. So if this clay material is not intended to use for construction, because of its size, because of its other deficiencies, that material which cannot be used as a construction material, so instead of wasting those material, I can powder it, I can burn it, and I can go ahead with producing the pozzolanic material. Next, when a clay is burnt in a kiln to make a pozzolana, when I want to use the clay as a pozzolanic material, it is desirable to select a soil which is of high proportions of clay. The soil should contain high proportion of clay. For example, if the soil contain more amount of sand instead of clay, then I need to sieve that soil and remove completely that sand, and remove completely the sand. Why? Because sand is a diluent, it is an inert material. That means the sand will not react with lime. The sand will not react with lime. It is an inert or diluent material. So hence, okay, if you comprise the soil comprises of more amount of sand, remove the sand, okay, in such a way that the soil contains high proportions of clay. In that particular way, you need to go ahead with a burning process. Now, after taking a clay soil, so what you are going to do? After taking a clay soil, mix it with water and make a square pieces. Okay, how? By after mixing, spread the clay soil like just like a cake, just like a cake, you spread it, okay, to a uniform, okay, thickness or whatever the surface on the hard surface. Later on, whatever the clay soil, the wet clay soil you have been spread, okay, which will be of a thickness as I stated 2.5 centimeter. The thickness will be 2.5 centimeter. So then slice that wet clay cakes, okay, to a size of 10 centimeter by 10 centimeter by 2.5 centimeter. Just like a cake, a square briquettes. So those are called briquettes, okay, of size 10 by 10 by 2.5 centimeter thickness. Okay, a square pieces, you just like cut that cakes. Then allow it to get hardened, okay, or allow it to get dry. And later on, after once it get dries, okay, take out that briquette pieces, okay, and then burn it in a kiln. Burn it in a kiln, okay, as I stated in the yesterday class, with the alternative layers of firewood, or with alternative layers of firewood. Okay, so by this way, okay, we can go ahead. So the amount of firewood used could be 10% of the weight of the clay with a temperature of about 700 degrees centigrade. Okay, and please note down whatever the kiln I'm using, there will be two types of kiln I can say. One is controlled kiln, another one is uncontrolled kiln. So in the villages, okay, when they are going to burn these things, okay, or whenever the bricks they are going to manufacture, okay, it will not be in the controlled manner. Simply they are going to make the fire to catch the fire, and they are going to burn for a specific time or a specific hours. Okay, controlled burning means to a suitable temperature, okay, I'm going to burn. That is called mechanized way. And mechanized burning has got more efficiency compared to the manual burning. Please note this point. Okay, now one more thing, since I'm using a firewood in order to get the briquettes, or in order to get a pozzolanic burnt clay, what I can say, the energy value of this is more. Please note this point, because these aspects also you should keep in mind. So as I told, whatever the alternative material you're using, okay, it should be locally available. So as far as possible, minimize the energy, okay, usage. Okay. Next, after burning, okay, it will be pulverized into a size of 90 micron, okay, in a ball mill. So ball mill is a device or an instrument or an apparatus, okay, that will break down the size, okay, and I can say to a suitable number of hours I am going to switch on, so that I can break down to a specific size, to the micro level, to the nano level. Okay, so I can bring down the, okay, size. And this ball mill has an efficiency, okay, in order to convert those burnt clay as a predominant pozzolanic material, okay, to get react with lime. So ball mill is a good device which will break down the, okay, the size of the pozzolana. So it will bring down the size of a pozzolana to micro level and to the nano level. Okay, so hence what they are going to do, to a specific number of hours they are going to burn it, so that they will get a good pozzolanic material. Okay, so this is what the way, okay, they are going to produce the powder burnt clay. Okay, so hope you have understood. Okay, next coming to the fly ash. So in this fly ash, okay, so first I will tell you how it will going to get. This fly ash is obtained from thermal power plant. Okay, so this fly ash will be obtained when they are going to burn the coal in order to produce the, okay, what? Electricity. So in the nuclear thermal power plant, Raichur, they are going to burn the coal. Okay, they are going to burn the coal. So after the burning of the coal process, okay, the ash will be, okay, liberated. So those ash, okay, which will start flying. The ash will be start flying. Okay, and those ash will be collected in electrostatic precipitator. We can see it. So those ash, because it is a very fine particle, because of its lesser specific gravity, it will start flying. Okay, so once the hash start flying, okay, in order to collect that, we are going to use a device called electrostatic precipitator. Okay, the ash in which you are going to collect the, okay, using electrostatic precipitator, so those ash are called fly ash. So please note this point. Okay, because in the same thermal power plant, you are also going to get some other types of ash also. That is pond ash, mound ash, bottom ash, and so on so. So all those things I will explain in the last topic, that is building materials from agro waste. So now it is not necessary. So we'll talk more about fly ash only. Okay, so fly ash will be obtained in nuclear thermal power plant. Okay, when the coal is burned in order to produce a power. Okay, the temperature they are going to burn is 1200, or more than I can say 1000 degrees centigrade. So this is the temperature they are going to burn. Okay, and as I stated, all the pozzolanic material will be significant, okay, in silica and alumina, and which will be amorphous. Whatever the pozzolana materials you are using, it is significant, but this silica will vary. Please note this. This silica and alumina will vary based upon the pozzolanic material. For example, in powder burnt clay it will be different silica, in fly ash it will be different silica. Did you get my point? So this silica and alumina will change based upon the burning process. Okay, and this fly ash they are going to do the controlled burning process, hence you are going to get a good pozzolanic material. So please note this point. Okay, so as I stated, the thermal power plant also consists of pond ash, bottom ash. So this pond ash, bottom ash is not a good pozzolanic material, so this cannot be used as a replacement for cement. Please note this point. I will talk more about this pond ash, what is bottom ash, all those things. Okay, so for time being, so please note that, okay, the thermal power plant comprises of fly ash, pond ash, bottom ash. Okay, so only fly ash can be used as a pozzolanic material, but not pond ash or bottom ash, because this pond ash and bottom ash is not amorphous and it will not react. So hence it is not a good pozzolanic material. And fly ash is a waste product, can be considered as a zero thermal energy, because you are not inducing any energy. Just you are burning a coal, and you are not burning a coal to produce fly ash. Please note this point. You are not burning a coal to produce fly ash. You are burning a coal to produce a power, in order to generate a power. While generating a power, okay, after burning a coal, the waste residue left out will be called fly ash. Did you get my point? But powder burnt clay, it is not that way. You are burning the clay in order to produce a pozzolanic material. So this is the difference between the powder burnt clay and a fly ash. So please note this point. Next. So coming to the next, rice husk. Okay, ash. Sorry, this will be ash. So the rice husk ash is a natural source of silica. So as I stated, so whatever the pozzolanic material you are using, it should be rich in silica. It contains 20% silica and rest is a combustible material. Okay. The silica is amorphous, and if the husk is burned, so whatever the information I've been given, it is a with respect to rice husk, not with respect to ash. So please note down. So the rice husk contains 20% silica and rest of its combustible material. This silica is amorphous, as I stated, and if the husk is burned under controlled condition, a higher pozzolanic can be produced. Okay, so you know that rice husk is a outer shell. Okay, so when you're going to grow the rice, okay, the outer particle, the outer shell, which will be in the brownish color, so those will be called as a rice husk. Okay, so those rice husk you're going to remove. Okay, After removing that, okay, so those rice husk, okay, will be left out. This will be waste. So those rice husk, why can't you use it as a fuel? Why can't you use it as a fuel? Instead of using firewood, instead of using coal, okay, why can't we go with a rice husk? It will act like a good fossil fuel. Okay, so by burning the rice husk, okay, in maybe in the factory, maybe in any, okay, thing, okay, you're going to produce a certain amount of ash. So those ash will be called as rice husk ash. Did you get my point? So those rice husk ash, when you're going to burn in a controlled, okay, and when you're going to get a controlled condition, that means you're going to burn the rice husk in a controlled condition. So whatever the ash you are going to obtain, which will be rich in silica, and you're going to get a good pozzolanic material. So with that instance, okay, I've been come up with a two, okay, methods. Okay, the personalities, okay, the famous personalities, they have been suggested two methods, and these methods are not, I can say, controlled burning methods. Okay, let me go ahead. So what method they have been suggested? The technique developed by Yoganand et al. So many persons burn the rice husk ash in an annular honeycomb brick as shown in figure 3.2. So I will show you. The brick structure is created and closely spaced mesh is placed at an height of 20 centimeter above the ground with an alternative layers of rice husk and clay were placed in a kiln such that husk is about 30 to 40% by weight of a clay. So whatever the clay you are been putting, so more amount of clay, less amount of husk. That means 30 to 40% by weight of clay you are putting. The width of the clay layer should be about 15 centimeter less than the width of the rice husk. You should be placed in such a way that, okay, the width of the clay layer should be less and width of the riser's cache should be more. Why? Because in order to permit the easy air movement through the bed, that means whatever the, okay, husk I am going to burn, okay, through that particles this fire should catch. So hence I am going to increase the width of the rice husk layer and decrease the width of clay layer. So with that context, you can see, okay, I've been set up the device. So you can see 90 centimeter width, 60 centimeter width. You can see, okay, this is the annular honeycomb brick structure. Annular honeycomb. So this is a brick structure. Okay, they have been, okay, laid, and this is the, okay, temporary setup they have been made. Sorry, for burning. Okay, at an height of 20. This may be concrete base. This may be concrete base. On above the concrete base, they are going to construct a 90, okay, height, okay, 90 centimeter height, I can say, okay, of annular honeycomb brick structure, and this is a wire mesh. Okay, so wire mesh they are going to place in order to send the uniform burning process. Is it clear? So in order to send the uniform burning process, okay, they are going to use this way. And later on, they are going to stock the clay and rice husk in the alternative layer, okay, in such a way that the clay width will be less and rice husk cache width will be more. So in that way, they are going to alternatively, okay, lay. So after that, see, the stock is now set fire from the below. So at this particular point. So at this particular point, they are going to make the catch the fire. Next, the entire mass burns over 1 or 2 days. So see, this is the drawback of manual burning. See, the limitations, you cannot get the material immediately. You need to wait till 1 or 2 days after, okay, burning, okay, the whatever the stock you are going to set fire from below. You need to wait for 2 days in order to get the pozzolanic material because you are burning manually. Okay, the end product is a mixture of, so it is a mixture of burnt clay and rice husk cache because I have been stocked clay also. So hence, whatever the powder that will be formed, it is a mixture of clay and rice husk. Later on, it will be ground. So please note this. Okay, in burnt clay also have been ground, but fly ash it is not necessary. Please note that. Fly ash it is not necessary to break down the size in the ball mill. It is, you can directly use ready to use material. Okay, but now, Okay, after burning, I need to grind it in ball mill, just like what we did in burnt clay, in order to obtain the fine pozzolana to a size of 90 micron or lesser than 90 micron. Okay, next. So this is the one technique they have been suggested. So one more technique they have been suggested, that is, in this technique, annular mesh enclosure in which rice cache is stopped and set to fire from below. So this is the rice burner. Okay, the entire mass burnt over several hours with central opening. So this is a hollow portion. So they have been left out with the opening. Acts as a chimney. So this will act, this 27.5 centimeter opening will act as a chimney. Next, a copper tube. Okay, it is a copper tube, okay, which is carrying. So this is called a copper tube. Okay, so the copper tube which carrying, okay, water may be inserted in the bed of the rice husk to generate hot water from the burning gas. So this is not, I can say, relevant. Okay, but you can produce hot water from this burning process. So that's what they have been highlighted here. Okay, and this technique also leads to good quality pozzolana. So let me explain how it is. So this is the way they are going to start. So this is the 20 centimeter height. Okay, they are going to, okay, prepare a bed. So now you can see they are going to provide this mesh, and this will be the copper tube. Okay, and this is the, okay, the hollow portion they have been made of 90 centimeter height and 27.5 centimeter width, and the entire device is of 75 centimeter, and this is an annular mesh enclosure. Okay, once again, whatever the mesh enclosure have been provided horizontally, I'm going to provide vertically also. So within this annular mesh enclosure, I am going to stock the rice husk. I'm going to stock only rice husk, no clay. So in the previous technique, in this particular technique, I used to stock both clay and rice husk. But in this technique, I am going to stock only rice husk. Is it clear? So now, okay, I'm going to make a, okay, catch a fire. Okay, so from bottom, I'm going to catch the fire. So after the burning process, okay, whatever the husk that is going to burn, okay, after complete burning process, whatever the ash we are going to obtain, so those ash will be called as rice husk ash. Is it clear? And there is a small mechanism they have been made in order to get a hot water. So during the burning process, they have been inserted a copper tubes. Okay, they have been inserted a copper tubes, and they used to send a cold water with these copper tubes. Because of this burning process, okay, they are going to get a hot water from the outlet. Okay, so this is the mechanism they have been made. Okay, there is no, okay, I can say, connection between the rice cache and this hot water. Did you get my point? Next, so in these two methods, which is the best pozzolanic material I can get? The first version leads to what may be called combination pozzolana, that is a mixture of burnt clay and rice husk. It is a combination material. The second technique has an advantage of producing a relatively large quantity of pozzolana. That means here you are going to get only rice as cash. Okay, hence you are going to get a large quantity of rice as cash. Okay, so in this they have also been quoted that the rice as cash we are going to produce, the national availability is 2 million tons, while the cement consumption is 100 million tons. That means still we can, okay, increase the rice's cash, okay, so that you can decrease the consumption of cement. Okay, so as I stated, footprint. Carbon footprint. Nowadays, everyone is talking about carbon footprint. So what they are going to do, because now I think, hope you know that whatever the cement you are getting, the L&T is stopped producing ordinary Portland cement. So many companies have stopped producing ordinary Portland cement. Why? Because while producing ordinary Portland cement, enormous limestone is going to be burned. Because of this enormous limestone they are going to use, while burning process, you know, already know that the carbon dioxide will be liberated. So this carbon dioxide, which will be very harmful greenhouse gases, okay, which will be liberated to the atmosphere. In order to take care of that, why can't we reduce Why can't we reduce those okay, consumption of cement and replace with a pozzolanic material? Okay, so the latest research says that the Pozzolana, whatever the Portland Pozzolana cement you people are using, they used to blend. They used to blend. Okay, I can say 20 to 30%. So this is a secret they are going to maintain. Okay, 20 to 30% fly ash they are going to blend with ordinary Portland cement in order to bring down the okay, the energy level, or I can say the carbon footprint. Carbon footprint. Okay, so that I can meet sustainable environment. Did you get my point? So these are the three types of pozzolanic material. So apart from this, we have so many pozzolanic material. So I used to do a lot of research. I'm conducting a lot of research with one of the locally available pozzolanic material, because in our locality, fly ash is not so easy to get. Please note this point. In our locality, fly ash is not so easy to get. Okay, so what I started to think, I need to search an alternative material or pozzolanic material in such a way that that is locally available and more predominant, okay, in Pozzolana. So in that context, in 2011 or 2012, I started my research with a material called bagasse ash or bagasse ash. So this is a material, okay, you are going to obtain predominantly in the southern part of Karnataka. I can say in Karnataka, okay, because 50 sugarcane factories are available. Okay, 50 sugarcane factories are available in the entire Karnataka, and we are the second largest producer of sugarcane in the entire world. India is the second largest producer of sugarcane in the world, and Karnataka stands third or fourth largest state in India produces sugarcane. Okay, so whatever in the sugarcane factory, they are going to crush the sugarcane in order to extract the sugarcane juice. So those extracted sugarcane juice, they are going to use in order to produce the sugar. So whatever the residue left out, okay, that sap is called bagasse. Okay, so those bagasse which will be rich in fiber, okay, so those fiber I am going to use it as a fossil fuel in sugarcane factory only, because hope you know that sugarcane factories initially they were facing a problem. Okay, in order to generate electricity power, they require okay enormous quantity of firewood or coal. So instead of going with a firewood or coal, why can't I go with bagasse only? So that bagasse they are going to use it as a fossil fuel. After burning the okay the bagasse as a fossil fuel, whatever the ash left out will be called bagasse ash. So those ash is also nothing but fly ash. So the ash will fly. So those ash will also be collected in a proper way, and we are going to replace. So till today I'm conducting lot of research on bagasse ash. So we have been doing a plenty of research in my laboratory, okay, in connection with bagasse ash from 2011 till today. Okay, so like this I've been developed a new pozzolanic material, okay, in this context. Okay, so like this, okay, you can also come up with various pozzolanic material. Okay, so there is a plenty of pozzolanic material available, plenty of pozzolanic material available, okay, in the I can say. But whatever the pozzolanic material you are going to use, so please note this point, it should be locally available. Okay, so please note this point, and you should put lesser embodied energy to make it useful. Okay, next. So with this discussion of raw material production, now let us produce lime pozzolana cement. Okay, so we know how to produce lime, we know how to produce pozzolana. Now let us blend these two components and produce lime pozzolana cement. So now let me define a mixture of finely ground calcium hydroxide, that is lime. Okay, so what I've been told, lime. Okay, after slaking the quicklime, the left out product will be called as calcium hydroxide or a lime. that is hydraulic lime. And the mixture of calcium hydroxide and pozzolana is known as lime pozzolana cement. Okay, the mixture of calcium hydroxide and pozzolana. Now the mixing plays a very important role here. How to blend these two components, because the blending component or blending of material is very important. If you blend the two material manually, the reaction will be different. If you blend the material, that is calcium hydroxide and pozzolana, in a machine, it will be different. So let us know, okay, how the blending process, okay, you are going to go ahead. An intimate mixture of lime and pozzolana will set in presence of water, forming calcium silicate and calcium aluminate compound. So this is the, I can say, the final product you are going to obtain. Okay, so calcium silicate hydrate and calcium aluminate. So how this lime and pozzolana, or I can say, when I'm going to mix the lime pozzolana cement with the water, how this, what I can say, the lime pozzolana cement will get strength, because once a lime and pozzolana is blended and mixed with water, okay, the whatever the compound that you're going to get is calcium silicate and calcium aluminate. So these compounds are responsible for setting and developing the strength in the case of lime pozzolana cement. Did you get my point? So in the traditional lime surki mortar, stocked lime and brick powder is used to mixed, okay, and ground in presence of moisture in bullock-driven mortar mills. Okay, for example, if you want to blend burnt clay, that is powder burnt clay and lime, okay, then, or if you want to produce lime surki mortar, so then you need to blend a calcium hydroxide and a powder burnt clay. How? You can use bullock driven motor mills. So earlier they were using, okay, nobody uses now. Okay, now they are going with a modern context. Instead of using this bullock driven motor mills, they can go with the power driven pan mills. Okay, so the power driven pan mills or pan mixers, they are going to use in order to blend this lime and surki or lime and pozzolana in order to produce mortar. Did you get my point? So now the efficiency of the lime pozzolana depends upon the intimacy of the mixing of lime and pozzolana. So this is very important. So the efficiencies of lime pozzolana cement will depend upon the intimacy of mixing lime and pozzolana. So I can say, you can they have been conducted several research on this. So depending upon the time of mixing, what will be the efficiency you are going to get. So that test they have been conducted. For example, if I mix the lime and pozzolana for 10 minutes, what will be the efficiency? If I mix lime and pozzolana for half an hour, what will be the efficiency? If I mix lime and pozzolana for 1 hour, what will be the efficiency? So those research they have been conducted by integrating the lime and pozzolana. And you can see here, one of the research they have been conducted, okay, that by integrating, okay, the lime and pozzolana for an hour, the strength of lime pozzolana sand mortar, that means mixture of lime sand mortar, can be increased to double the value. Okay, that means you can attain the strength more than the lime pozzolana cement. Okay, so that is the fantastic thing you can achieve from this lime pozzolana cement. So with this, the predominant, I can say, okay, the proud institution, Indian Institute of Science, Bangalore, okay, Department of Civil Engineering, have developed the two alternative techniques to produce lime pozzolana cement. Okay, so those techniques are dry blending and wet blending. Okay, so let us know that how to go ahead with dry blending. The slaked lime, that is calcium hydroxide, and pozzolana should be separately processed as dry powder. That means they should be grind separately first. The pozzolana should be grind or dried in such a way that to a fineness of 90 micron. To a fineness of 90 micron, that should be grind. The two powders may now be blended in a ball mill for a duration of about 1 hour. After processing separately, now those two mixtures they are going to blend in a ball mill. See, this is the device that was using to reduce the size. Now I am using it for mixing also for duration of 1 hour. In these techniques, the size reduction of lime and pozzolana is carried out first, and then the mixing of two is carried out subsequently. So that's what I have been told. If you want to reduce the size of this lime and pozzolana, so you are going to use a ball mill, and subsequently this ball mill you can go ahead with the mixing process. So by this way you can go ahead with the mixing process. This mixture is then added to the sand, and after drying, mixing water is added to come. That means this is the preparation process of LPC. Now, if you want to go ahead with lime pozzolana cement mortar, so whatever the mixture you have been prepared, then you are going to add with the sand and add a water to that dry mixing, okay, mixture, and then you can prepare a mortar. This procedure is also means that dry mixture of L and P, that is lime and pozzolana, has to be stored properly in a bags, because we know that the lime has a tendency to react with moisture. That is the drawback of storing the lime. So that's why they should be stored in properly LDPE bags, low density polyethylene bags or gunny bags properly. So in order to increase the service life of that lime. Okay, did you get my point? So otherwise the lime will start reacting. So I've been quoted one example. See here, if you're going to store the bags, LDP bags for 21 days, okay, that is lime and pozzolana dry mixture, it will reduce 60% reduction after 45 days of storage. Okay, after 45 days of storage, when stored in impervious plastics or paper bags, the strength fall is about 35% after 45 days of storage. So this is the reduction in strength you can see, okay, when you're going to store the lime pozzolana mixtures in LDPE bags. So this is the same in the case of cement bag also. So we need to stock the material in a proper way, and we need to utilize the materials in a proper way, and we need not to stock the material for more number of days. If you're going to store a more number of days, it will decreases the service life of the, okay, the material. The residual moisture present in lime or pozzolana will initiate reaction between the two, even when stored in dry condition. That's what I've been told. Okay, whatever the moisture that will be present in the lime. So another drawback, apart from absorbing moisture from the atmosphere, because whatever the lime have been mixed with the pozzolana will be calcium hydroxide. Okay, that means the lime is already contain the water. Okay, so those, okay, the calcium hydroxide when it mixed with pozzolana, it will react. Okay, because a pozzolana has a tendency to react with lime in presence of the moisture. So this reaction will happen, okay, and it may get hardened. So that, okay, if you store for a number of days, it will lose its performance, so that it will become, okay, not useful material, or you cannot use that material. It is important to note that blending dry mixture of lime and pozzolana should not be stored for more than 14 days. So this is the, okay, they come up with a condition. If the strength reduction is to be lesser than 10%. So if you're expecting, okay, lesser than 10%, or if you want to use it properly, don't store the lime and pozzolana mixture for more than 14 days. So within 14 days, use the material. So this is the dry blending process. Next, go to the wet blending process. Now the pozzolana has to be produced and ground to a fineness of 90 micron and stored in gunny bags, LDPE bags. The pozzolana can be stored indefinitely, fine. Okay, slaked lime and freshly produced by slaking quicklime at the site. Okay, that means you are going to add a water. The slaked lime and freshly produced by slaking quicklime at the site. So same thing have been repeated here. The slaked lime and well-ground pozzolana may now be mixed in simple drum or hand operated concrete mixture in presence of water. So that means the slaked lime, that is calcium hydroxide, and well grounded pozzolana, that is of 90 micron, okay, mixed in a simple drum, okay, with the water, with the water. So after blending these two for 80 minutes, you can see they have mixed for 80 minutes. The lime pozzolana slurry may be poured over sand, okay, and thoroughly you can produce lime pozzolana. So now this wet blending you can go at only when you're going with the construction activities. So when you're going to start with construction activity, at that particular instance, you can go with wet blending, because you cannot store the wet blending. Please note this point. You cannot store the wet blending. So once if you're going to start with construction activity, at that instance, you can mix the calcium hydroxide, the well-grounded pozzolana and the water properly, and later on pour the sand, and you can prepare the good lime pozzolana cement mixture or mortar, I can say. And very important, 80 minutes. So you can see this is the research they have been performed. So till 80 minutes, the lime pozzolana mortar have not shown its good performance, have not shown its good performance. So that's what I've been told. These are all the drawbacks in the case of lime. These are all the drawbacks are there in the case of lime. Okay, you need to go ahead with the more time of mixing. So this is regarding the production process of LPC. Hope you have understood. So now come to the very important thing, properties and uses. Okay, so I've been short. Okay, because finally whatever I've been produced, finally it should perform. Am I right? It should perform well. It should function well. So those things I'm going to assess with the properties. So let me go ahead. Several studies were carried out to determine the typical strength of lime pozzolana mortar using burnt clay and combination pozzolana. Okay. Typical results of lime burnt clay pozzolana based mortar are shown in table 3.1. It can be seen that 28 days strength of most of the mortars are above the BS code requirement, which is 3 MPa, because the Indian code has clearly specified whatever the mortar you people are producing, it should possess a strength of 3 megapascal at 28 days. So those strength I can easily obtain with this lime pozzolana cement. Okay, so hence I think this is a best alternative building material. I can go ahead, okay, instead of using conventional cement mortar. It is, however, maybe note that the bulk density of lime burnt clay mixture is quite low. So this is the limitation, or I can say, okay, the disadvantage in the lime clay mixture. And hence the mortar proportion by volume are quite rich compared to the usual cement mortar proportion. Because of the, okay, bulk density, lesser bulk density, okay, the mix will become very rich in volume wise. Okay, this means that greater proportion of lime pozzolana cement has to be used to achieve satisfactory mortar strength. Okay, you need to go with a greater proportion. So let me go ahead. So now please see here, I've been taken a red soil, okay, from a particular source. That's why I've been one. I've been grinded to a lesser than 90 micron after producing. Okay, I have not been grinded. Okay, anything. Okay, just I mixed it, I grind it, and I'm readily using that. So with a mixture of lime 1, pozzolana 2, and with a sand 9 part by weight. So the 7 days strength is 3.2 and 28 days strength is 5.4. For the same red soil, if I'm going to procure from another source, lesser than 90 micron, okay, I can say the same soil source. If I'm going to intergrind the lime pozzolana before mixing the sand, if I'm going to intergrind the lime and pozzolana for 30 minutes with the same proportion, you can see the magic it does. 4.3, 6.1 because of intergrinding for 30 minutes. Next, consider the black soil. Okay, instead of red soil, consider the black soil and grind it to lesser than 90 micron. Okay, by burning and all those process. Next, intergrind the lime and pozzolana for a 30 minutes with the same proportion. I can get 2.4 for 7 days, and you can see the magic 5.1 MPa. Okay, that means intergrinding of lime and pozzolana will lead to the better proportion, or I can say better compressive strength. Next, tiles powder, grind it to lesser than 90 micron for 30 minutes. Okay, mix it with this combination. You can see the fantastic magic it does. Okay, 7.7 MPa you can obtain. Like that, if you're going with the brick powder, okay, I can see that you can reduce the size now. Please see here, sorry, increase the size now. Instead of going with 90 micron size, let me go with lesser than 600 micron. What will be the change? And if you know grinding is suggested with change in proportion, you can see enormous decrease in compressive strength. Did you get my point? So the proportion of clay and rice as cash is indicated to help understand the clay rice as cash ratio. It can be seen that when burnt clay and rice as cash are separately produced, adequate rice as cash can added to provide strength. That means combination. The mortars are so strong that the sand content has to be increased to provide the usual mortar strength. So this is the drawback. You can see here, in order to obtain the strength of this much for a lime pozzolana mixture, the drawback is you need to increase the sand content here. Please note this point. Okay. Next, when the rice cash is used to burn the clay, the process becomes more economical, but the strength are moderate. A clay rice cash ratio of 1 is to 0 is to 6, sorry, 1 is to 0.6 is ideal from the point of view of strength and economy. So they have been conducted a lot of research, okay, based on this, okay, and they have come up with these results. So I can say that when you expect a strength of very less, okay, you people can go with lime pozzolana cement based composites. You can go with lime pozzolana based cement composite. You can produce a mortar, okay, because as I stated, you can use, okay, this mortar for a lesser or low strength applications like plastering, for bed joints, for all those things. You can go with a lime pozzolana cement instead of using alternate, okay, that means instead of using, I can say, the conventional cement mortar. So by this, it will become a best alternative construction material or building material. You can go ahead instead of using ordinary Portland cement mortar. Is it clear? So like this, okay, I can go ahead with the lime pozzolana cement process or producing process. So hope you have understood completely how to produce this. Okay. Thank you for joining.